Okay, this is, I think, the last trigonometry question, and they give you this big triangle that's in 3 dimensions. They tell you a few things. They say the point, well, let's just read it. Here we go. T is a hook on the ceiling of an art gallery. I didn't read all that. I just looked at the triangle. Q, S, and R are on the same horizontal plane, and they made it in a nice grayish blue so you can see the plane that's down here. They've got two sides being equal, TS and QS. They say the angle of elevation from Q to T is X, so that little angle in there is X. Okay. And they tell us that QSR is 90 plus X degrees, right where QSR, that angle right there. QRS is also equal to X. QR is equal to 5 units. And TS, like I said before, is equal to QS. Okay, there's the whole thing. Prove that QS equals 5 tan X. Do you know, in so many of these 2D or 3D trig problems, the law of sines is such a useful thing. It comes up more than anything else. And here it is right here. We can just look at this gray part right here and go, oh, QS, that's what we're talking about. What angle does it go with? X. So QS over sine X equals the side 5 units that goes with the sine of 90 plus X. Well, that's it. Just sine rule. That's all you use. It's not so hard. The sine of 90 plus x is equal to cos x. That's a cofunction you need to know. And then I multiply sine x up here, and ooh, I'm looking at my answer. 5 sine x over cos x is tan x. So I just proved that QS equals 5 tan x. Let's look at the next part. Ooh, prove that the angle QT, the length of QT, is 10 sine x. I think maybe that's the next one. Prove that the length of QT, this QT here, is equal to 10 sine x. Well, I started off, we know now that QS is equal to 5 tan x. We just proved that. QTX, I looked at this right away. QTS, this up here, if that's x and those two sides are equal, that angle's equal there. Angles opposite equal sides. I know I'm going to need that at some stage. So, in fact, right coming up, I want to get at this angle right here, TSQ. Well, if that's x and that's x, TSQ must be 180 minus 2x. That's angles sum in a triangle. You just go 180 minus these two added together. And hey, we're trying to get at QT. And it's time to use, we know that this is 180 minus 2x now. Maybe I should write it in. 180 minus 2x. I'll just put it in there so we can see it. You can look at it in the picture there. I know that angle's there because I know that angle up there is x. Okay, let's put it in there and take a look at it. Right there. Okay, that kind of makes sense. 180 minus those two x's, that's that angle. Hey, we're going to use the sine rule again. QT goes with this angle here, and QS goes with x. Well, there it is. But QS, hey, we figured out that that was 5 tan x, so we can rub it out and put 5 tan x. And we should know a major thing with sine angles is the sine of an angle is the same as the sine of 180 minus that angle. So the sine of 180 minus 2x is just the sine of 2x. And hey, the sine of 2x is 2 sine x cos x. That's on my identity sheet. And tangent is sine over cos. And now it's time to cancel a bunch of stuff. Cos x cancels with cos x. Sine x cancels with sine x, and all you're left with is 5 times 2, which is 10, sine x. And that's what we were supposed to prove. Let's just do the last question because I think we might as well finish off question 8. Now we know that this is QT is 10 sine x. They tell us that QTR is 70 degrees. We know this is 5 units, and we're asked to calculate the area. Well, just use the area rule because we've got this green thing here, TRQ. We've got the angle in between and the two sides on either side. 1/2 AB times the sine of the angle in between those two sides, that we're multiplying together. So 1/2 TQ times QR times the sine TQR. Well, they gave us that with 70 degrees. They gave us QR is 5 units. And we've got that QT is 10 sine 25 degrees. Just put it all in your calculator and you get 9,93 square units. And there you go.